Hello everyone. Let me introduce myself to you. I am Dr.Ch.Venkateswara, Assistant Professor, PG Department of Chemistry, Sri Vayan College, Narsapur. I am here to provide fundamental concepts in physical chemistry. As far as my knowledge and experience is concerned, most of the students do not aware of fundamental concepts in chemistry and often do feel ambiguity in learning chemistry. If students do aware of fundamental concepts in chemistry, can excel in their careers. Therefore, this is my endeavor to provide concept-oriented lectures which enables students to feel free in learning chemistry. Therefore, I shall make an attempt to teach chemistry in this online mode in a simplest possible manner that I can. The subject chemistry has wide range of applications and it is ranging from pencil to planet and matchbox to missile. Moreover, an innovation starts with a single thought. And a million miles of journey starts with a single footstep. And of course, the subject chemistry has no exception for that. And the subject chemistry starts with the elements and compounds. Let us start our learning by knowing the difference between elements and compounds. An element is the simplest and purest form of any chemical substance which is made of only one type of atoms. And an atom is the simplest unit of matter. For example, the element hydrogen contains atoms which is made of only one proton and one electron and without a neutron. Of course, you may find one or two neutrons for the hydrogen atom, and that is the case which introduces the concept of isotopes. Therefore, an atom represents an element and it is characterized by its atomic number in the elements of periodic table. And every atom has its own atomic number. Moreover, the physical and chemical properties of elements are periodic functions of their atomic numbers. I shall explain the concept of isotopes in this context. By the virtue of etymology of isotope, iso means same, topos means place. That means isotopes occupy same place in the elements of periodic table. For example, hydrogen element. The element hydrogen has three isotopes that are protium 1H1, deuterium 1H2 and tritium 1H3. And the three isotopes are being represented by element hydrogen 1H1 1.008. Therefore, the atomic number of hydrogen element is 1 and its atomic weight is 1.008. And the atomic weight that we observe in the elements of periodic table is the weighted average of atomic weights of its isotopes. Let me go for another example. If you take the chlorine element, that is 17 chlorine, and the element chlorine has atomic number 17 and the element chlorine has two isotopes that are 17 chlorine 35 and 17 chlorine 37, and these two isotopes are being represented by 17 chlorine 35.5 in the elements of periodic table. Already I told you the atomic weight that we observe in the elements of periodic table is the weighted average of atomic weights of isotopes of that element have. Let me calculate the weighted average of isotopes. In nature, the isotope 17Cl35 abundance is 75%. That is 3 by 4. And the isotope 17 chlorine 37 abundance is 25%. That is 1 by 4. Let us calculate the weighted average of these two isotopes. That can be calculated as 3 by 4 into 35 plus 1 by 4 into 37, which comes out to be 35.5. Therefore, this is the weighted average of atomic weights of these two isotopes, and it is being represented in the elements of periodic table. Now, compounds. Now, compounds. Compounds, chemical bonds links the elements to form more complicated molecules called compounds. That is, a compound contains one or two elements that are held together by covalent or ionic bonds. Let us see the examples for compounds. HCl, NaCl, sodium hydroxide, AgNO3. These are the examples for chemical compounds. And in the HCl molecule, the elements hydrogen and chlorine are held together by covalent bonds. And in the NaCl, the element sodium and chlorine are held together by ionic bonds. Okay, in this way, chemical compounds are formed. And let me pose one question to you. H2, Cl2, P4, S8. Are these elements or compounds or atoms? To understand this concept, you should know the concept of atomicity. Atomicity refers to a number of atoms in one molecule of an element. That is H2. It is formed by the two hydrogen atoms. Cl2. It is formed by the two chlorine atoms. P4. And it is formed by the 4 phosphorus atoms. S8, it is formed by the 8 sulfur atoms. So, by the definition, an element is formed by the same type of atoms. Therefore, all these are examples for elements. For example, S8 is element, P4 is element, chlorine, Cl2 is element, H2 is element. And we can say that H2 and Cl2 are as elements. Of course, that are formed by the two hydrogen atoms, and the two hydrogen atoms are held together by a covalent bond. Now, I shall explain the concept of mole. In the universe, whatever the concept or whatever the thing is, it is customary to quantify it. For example, if you take water, that is being quantified in liters, and if you take sugar, that is being quantified in kgs. Similarly, chemical substances or chemical compounds are being quantified in moles. It should be kept in your mind that chemical compounds or chemical substances are being quantified in moles. The term mole was first introduced by Ostwald, and it is defined as amount of matter that contain as many objects as the same number of atoms in exactly 12 grams of carbon-12. We can sum up this definition with a single equation, that is number of objects is equal to number of moles into number of objects per mole. Where number of objects per mole, that is being represented by Na. Of course, you may know the constant value, and that constant is known as Avogadro's constant, and whose value is 6.023 into 10 to the power of 23. And simply we can represent this equation as number of moles is equal to number of objects by number of objects per mole. Usually this equation can be represented as number of moles is equal to weight in grams by gram atomic weight. Therefore, number of moles or mole is equal to weight in grams by gram atomic weight. Another term, gram atom, is used specifically for elements which is just equivalent to 1 mole atoms of that element. Therefore, gram atom is equal to mole is equal to weight in grams by gram atomic weight. Here the term gram atom is confined to elements. Besides this gram atom, there is also gram molecule. I shall explain this gram molecule in the further class. Therefore, gram molecule is equal to gram atom is equal to mole, and that is equal to weight in grams by gram atomic weight. Let me clear this concept with the help of a small problem. In 4 gram atom of Ag, calculate weight of Ag and weight of 1 atom of Ag. Here 4 gram atom means 4 moles of Ag, and we know gram atom is equal to weight by gram atomic weight. That is, weight is the gram atom that is given as 4 is equal to weight by gram atomic weight. Therefore, gram atomic weight of silver is 108 grams, and therefore weight is equal to 4 into 108, that is equal to 432 grams. Therefore, 4 gram atom or 4 moles of Ag contains 432 grams of Ag. And one more thing is kept in your mind, that 1 gram atom is equal to 1 mole. 1 mole is equal to gram atom, 1 gram atom, and gram atom is equal to weight by gram atomic weight, and 1 gram atomic weight of Ag also equals to 1 mole. Okay, let me explain this concept with another example. Weight of 1 atom of Ag. Weight of 1 atom of G. We can calculate weight of 1 atom of Ag. That is, we know 1 mole of Ag. 1 mole of Ag is equal to 108 grams. 1 mole of Ag is equal to 108 grams. And already I told you 1 mole of any substance contains 6.023 into 10 to the power of 23 molecules. That is Avogadro number. Of course, you all know that very well. Therefore, 108 grams of Ag contains 6.023 into 10 to the power of 23 atoms. And what they asked, weight of 1 atom of Ag. So here 108 grams of Ag contains 6.023 in 10 to the power of 23 atoms. You please revert this equation. That means 6.023 into 10 to the power of 23 atoms of Ag weighs 108 grams. Therefore, you can simply calculate the 1 atom of Ag. 1 atom of Ag. So 6.023 in 10 to the power of 23 atoms of Ag weighs 108 grams, and 1 atom of Ag weighs, that is 108 grams by 6.023 into 10 to the power of 23. That gives 1 atom of Ag. So this is 108 grams. This 108 grams is equal to 6.023 10 to the power of 23 atoms. That means 1 atom of Ag weighs 108 grams by 6.023 into 10 to the power of 23. Okay, therefore 1 mole equal to 1 gram atom is equal to weight by gram atomic weight, and it is equal to Avogadro number of atoms. Let me go for another example. One mole of AgNO3. 1 mole of AgNO3. Of course, 1 mole of AgNO3 is equal to gram molecule of that compound. Gram molecule of that compound. Gram molecule, or gram molecular weight, or gram molecular weight of that compound. We can calculate the gram molecular weight of AgNO3 by adding the gram atomic weight of Ag, gram atomic weight of nitrogen, and gram atomic weight of oxygen. By summing all these atomic weights, we can get the gram atomic weight. And gram atomic weight is simply known as a gram molecule, and it is equal to 1 mole. Therefore, 1 mole is equal to 1 gram atom, and 1 gram atom and is equal to weight by gram atomic weight, and it is equal to Avogadro number of atoms. So that is next. 1 mole of AgNO3 is equal to gram molecule, and it is equal to gram molecular weight. And 1 mole of AgNO3 contains 6.023 into 10 to the power of 23 molecules. And our Avogadro number of Ag plus ions, or Avogadro number of NO3 minus ions, And of course, these Ag plus and NO3 minus ions are held together by ionic bonds. Therefore, 1 mole is equal to 1 gram atom is equal to weight by grammatic weight into Avogadro number of atoms and is equal to gram molecule or gram molecular weight. Gram molecule or gram molecular weight. Now, and there is another standard unit is there to quantify the chemical substances that is atomic mass unit. So by atomic mass unit, okay, which is equal to 1.6 into 10 to the power of minus 24 grams. And atomic mass unit is defined as 1/1/12 of mass of one atom of carbon 12. That is simple. 1/12 of mass of one carbon atom into 10 to the power of minus 23 grams, which comes out to be 1.6 into 10 to the power of minus 24 grams. So, one atomic mass unit is equal to 1.6 into 10 to the power of minus 24 grams. And in this context, I shall explain how we calculate the Avogadro's constant. Already I told you one AV is equal to 1.6 into 10 to the power of minus 24 grams, and one atom of carbon weighs 1.9 into 10 to the power of minus 23 grams, and this is equal to one atom of carbon, that is measured by the mass spectrometer. And 1 mole of carbon contains 1 mole of carbon equal to 1 mole of carbon is equal to already we know that 1 mole is equal to gram atomic weight of that element. For example, 1 mole of carbon is equal to gram atomic weight of carbon is equal to 12 grams. So 12 grams equal to 1 mole of carbon, and this 12 grams of carbon contains 6.023 into 10 to the power of 23 atoms. How we calculate and how can we get 6.023 10 to the power of 23? It is very simple. 12 grams, 1 mole of carbon contains 12 grams of 12 grams, and it contains 6.023 10 to the power of 23 atoms. We can divide the 12 grams by 1 atom of carbon, 1.9 into 10 to the power of minus 23. That gives the Avogadro's constant 6.023 into 10 to the power of 23. So this is the and in this way we can calculate the Avogadro's constant. Now we shall sum up this mole concept as mole is equal to gram atom, and it is equal to weight by gram atomic weight, and it is equal to Avogadro's constant, and it is equal to gram molecule or gram molecular weight. Scientist Avogadro extended this mole concept to gases and formulated a hypothesis called Avogadro's hypothesis, which states that equal volumes of all gases under similar conditions of temperature and pressure contains equal number of molecules, and 1 mole of gas occupies 22.4 liters volume. Therefore, 1 mole gas occupies 22.4 liters volume, and 1 mole of that gas contains 6.023 into 10 to the power of 23 atoms or molecules. Therefore, we can sum up all these concepts as number of moles of atoms. When we want to calculate the number of moles of atoms, weight by gram atomic weight is the formula. And when we want to calculate the number of moles of molecules, then we have to use the formula weight by gram molecular weight or molar mass. And when we want to calculate the number of moles of gas is equal to, then we volume of gas by 22.4 liters. Therefore, mole is equal to gram atom is equal to weight by gram atomic weight, and it is equal to Avogadro's constant, and it is equal to gram molecular weight. And when we want to calculate the number of moles of atoms, we use this formula, and when we want to calculate the number of moles of molecules, we have to use this formula, and when we calculate the number of moles of gas, we use this formula. I hope you understand this mole concept. In the next video, we shall discuss the applications of this mole concept. Thank you.